area under the curve with constant c. To the right is the graph of f prime of x. Okay, I think I'll write that down. Prime of x. Okay, which is the derivative of f of x. F prime of x consists of two line segments and a semicircle as shown. If f of 2 equals 1, then f of negative 5 equals. Okay, so we're given f prime of x. So let's start off by looking at, we want to find f of negative 5. F of negative 5 equals question mark. And we're given f of 2. So f of 2 equals 1. So we're saying this is f of 2 right there. And this is f prime of x. So the integral of f prime of x will be f of x. Okay, I think we got something here. So if we integrate from negative 5 to 2 of f prime of x dx, this will give us f of 2 minus f of 5. So you're used to seeing f right here, an integral with f of x gives you something like this. You're talking about integrals here. But since we're given f prime of x, it's kind of like we shifted the whole integral thing to one direction. So just to go over what I wrote here real quick and try and convince you that it's actually correct, or at least mostly correct. So we have f prime of x right here. Line, half circle, line. We're told that f of 2 equals 1 right here. And therefore, if we take the integral of f prime of x from negative 5 to 2, which is integral from here to there, then that will give us f of 2 minus f of 5. Because we're taking something that's already a derivative and making it not a derivative. And so if we think about this, then we can find this using area under the curve, because that's the idea, that's the definition of an integral. Area under a curve, and we're given that f of 2 equals 1. So we can find what f of 5 is. So let's see right here, make an arrow, negative 5, integral 2, f prime of x dx. Okay, and so we're going to zoom in on here. So we have f prime of x here. So right here we will have, that's what, 1, 2, 3 by 2. 2 times 3 is 6. 6 divided by 2 is 3. So the area of this triangle will be 3. Here we have a half circle. And the area of a circle over 2 is pi r squared over 2. Or in this case, r is 1, 2. So this will be pi times 2 squared, which is 4, over 2, which will be 2 pi. And this is below the x-axis, so it will be negative 2 pi. So we have 3 minus 2 pi. 3 minus 2 pi. And then we know from our equation over here that we just wrote up, this will equal f of 2 minus f of negative 5. F of 2 was given as 1. So this will be 1 minus f of negative 5. 3 minus 2 pi. I know it's looking a little bit messy, a little disordered. That's okay, part of life. And so what we want to do then is solve for f of negative 5. So to do that, we'll move it over to this side. We'll take the 3 minus 2 pi, move it over to this side. And so we have f of negative 5 equals 1 minus 3 minus negative 2 pi. That should be a little bit less messy. Okay, so we have 1 minus 3, which will be negative 2. And then we'll add 2 pi. So it'll be 2 pi minus 2. Minus 2. So f of negative 5 is 2 pi minus 2, which is even a possible answer, which is nice. So this really kind of felt like it just came out of nowhere. So to backtrack real quick, let's go over what happened here. So what we were given was, all right, we have f prime of x is our graph. So if we take the integral of f prime of x, we get just normal f of x. So we're given f of 2, and we're given f of negative 5. So if we take the integral from negative 5 to 2, negative 5 to 2, we get f of 2 minus f of 5. And we don't usually normally do that, but it's how the math falls out. And we, even though we're normally used to using integrals, big F's, small f's work too. And so this is kind of how the math falls out. And then from there, we just solve pieces of it. We can solve the integral portion by just finding the area under the curve. We have a triangle and a half circle. And then we can find f of 2 because it's just given to us. After that, we rearrange. And what we're given is we have f of negative 5 equals, and we have it right here, 2 pi negative 2.